Hello, today we're going to show you how to make a Unity game from scratch, from no assets in the scene whatsoever, just a blank project. So I got my old Unity hub open here. To start a new project, you come down to this little blue button here, and either you select new, or you can select this little drop down, and it will bring up all the Unity versions you have installed. I've got way too many, but I'm just going to hit new, and it should use the latest version, or whichever one you've got set as your default, which is in that fact not the latest version for me. I want to... I don't know how you do actually set this as default. No, never mind. I'll just hit new. It's the last project. Okay. Okay, I'm going to go with just 2019.4.12. And we're going to hit this button that says 3D here. So when you're creating a new project, you can select 2D, and that will kind of set up your scene to use 2D by default. And there's also 3D with extras, just adds a few more assets. And high definition render pipeline and universal render pipeline are kind of new things in Unity, which we're kind of not gonna avoid that for now because that's complicated. I'm just gonna hit 3D. There's also kind of these built-in projects here, but we'll just go with 3D and we'll call it, I don't know, Unity session number 2. And hit create. Now it's going to take a while to actually like open Unity and set up this project. So if you've got anything you want to ask in the meantime, go ahead.
Did you actually record it?
I should be recording. Bloop.
Ooh.
OBS says it's recording, so hopefully we good. Is the stream still working okay?
Yeah. Crisp. Beautiful.
Crisp 1080p, 15 frames per second. The way God intended.
Yeah. Frame rate of real life.
Your eyes cannot perceive above 15 frames per second. It's been proven by science.
True. Caveman brains couldn't think more than 15 times in a second. It's an affront to God. Anything higher than that.
So as I said, this might take a while to actually open a new project.
I'm guessing you'll just like edit this part out, right?
Probably, yeah.
Was the old? Did you upload the last one?
I uploaded the last one, yeah. The link is somewhere in the announcements channel. I'll probably put it like in hash resources as well. Right, so here is a blank project. As we kind of discussed last time, you have the scene view here, and the project contains everything that you can add to your scene, but it's empty apart from this default sample scene. So I guess to start off, we'll just kind of work around adding objects to the scene. Does that kind of sound okay, Joshua?
Yeah, that's fine.
So Unity comes with a few kind of default objects that you can add to your game. So if you go to this game object menu, it has kind of these lists of things you can add by default. So for our 3D game, it has these kind of primitive models. So I've got a cube, sphere, capsule, cylinder, a plane, and a quad. Although the plane is just loads of quads stitched together. There's some more advanced things like text, which is just 3D text that hovers in the game. Ragdoll, which you probably know what a ragdoll is. It's a physics-enabled character model that just flops around due to gravity. Stuff like terrains, trees, and wind zones, these are all kind of used together. So you can build trees and put them on a terrain and paint them automatically. And, well, 3D text, which I think is the old text, the old 3D text. So this is very annoying, and it actually has 2 versions of this now. But to start off with, we'll just add, say, a cube. And that should add a cube to our scene. So, as we said last week, we can use the same kind of navigation tools. So I'm just going to press F and that will frame select around the cube. One thing you'll notice by default here is that I've actually got shaded wireframe on here. I'm going to put it back to shaded. There's some options here to change how Unity renders things in the scene view. So if you want to just see wireframes or a shaded view, or both, I'm going to keep it on shaded just because wireframes look weird in the scene view, I guess. Yeah, one thing you'll see is that the lighting on this cube is a little bit awkward. So I think I can just press this auto generate lighting off. It opens up the lighting tab, which, as there's another thing to mention, is that tabs in Unity you can just drag anywhere you want. So I'm going to dock this next to the inspector. To make this lighting not look off all the time while I'm working on my game, I will click the auto generate tick box and it will generate more realistic lighting for us. So that's just basically adding an object. There's other things that you can add if you so wish.
If you add a plane.
Hmm?
If you add a plane.
Yeah, sorry, I'll just turn up my sound because it was quite quiet for me. Yeah, we'll add a plane.
You add a plane.
Yeah. Right. So that's what a plane looks like.
Interesting things about a plane is it's actually one directional in where you can see. If you look underneath, it will be invisible.
Yeah. So when you add an object, it kind of centers it in the middle of the camera view. So if you look at the position here, it's kind of off. It's not on center. So either we can type 000 in this position box if you wanted to center it, or you can just click reset from this little hamburger menu. Just click reset, and it sticks it right in the middle. I suppose we'll talk about the kind of things that are attached to these objects that you've added. So if we click on the plane again, we'll notice that it has a few things kind of attached to it. Each of these is a component. So the way Unity's kind of game object model works is that you have game objects, which are conceptually anything that can be in your game. So that could be like this plane, which could be a floor, it could be a character, it could be an enemy, etc. And each of these game objects have components attached. So a component is, it encapsulates something about those objects. So for a floor, you would probably have a collider. So a collider will stop things from falling through it. For a player or an enemy, you'll probably have some kind of movement script. For an enemy, you might have some kind of AI that kind of snaps it to the floor and navigates around to find the player. And for the plane, we have 4 components. Every component, every game object has the transform component, which dictates where it is, how it's rotated, how big it is, what its scale is. And it has a mesh filter. So a mesh filter is the component that determines what the mesh looks like. So for a plane, in fact going into wireframe mode will be quite useful here. For the plane, the mesh is made up of loads of little vertices and loads of faces between those vertices. So it's actually, I think, 10 by 10 vertices on each side. Yeah. Go back to shaded. Go back on the plane. So the mesh filter defines what that... Well, you can pass in any mesh you want here. So I could mess around with it and for some reason add the... I can change the mesh to something else if I wanted, but that's kind of weird. So I'll leave it as it is. We have the mesh renderer, which is the component that reads what the mesh filter data kind of passes to it. It reads that and it applies materials to that object, or to that mesh. So we talked briefly about materials in the last session, but a material just encapsulates kind of rendering properties about an object. So the default material just says this is a white object, it's not particularly reflective, you know, it's kind of a matte surface. It also controls stuff like lighting. So we can tell it to cast or receive shadows. So if we click receive shadows off, for example, the shadow cast by the cube will no longer turn up on this plane. We turn on global illumination. That's kind of a more advanced lighting topic. So are light probes. They're a bit more advanced. So global illumination and light probes are used. Well, global illumination is a lighting system that just does indirect lighting. So if I had, say, a very reflective surface, it can take in lighting that bounces off other things in the scene. And light probes are a way to bake that reflection data into kind of a more efficient representation rather than calculating all the lighting at runtime. But as I say, these are kind of slightly more advanced lighting topics. And then there's some additional settings here which kind of you don't need to worry about. And then the last component is the mesh collider. So the collider is a physics component that stops things falling through it. So in fact, if we were to turn off the mesh renderer, we'll see that the mesh collider is exactly the same mesh as the mesh filter, and that's because this is, as I said, a mesh collider. There's other kinds of collider, so if we were to go on the cube, rather than a mesh collider, it's got a box collider. So the box collider is, as you would imagine, I don't know how well it turns up on the, it's just a cube. This could be a mesh renderer and it would look exactly the same because the mesh attached to this object is indeed a cube, but a box collider ends up being slightly more efficient than having a box-shaped mesh collider, if that makes sense. Right, that's just kind of the basics of components that can be attached to objects. Are there any questions so far? Are we going too slow, too fast, too waffly? Or is that good?
I mean, I think if you cut out the advanced lighting stuff.
Yeah, I'll kind of cut out bits of this when I upload it to the YouTube.
Doing editing.
Yeah, I'm gonna try and edit out some of the less relevant parts. Okay, we'll move on then.
I mean, should we move on to basic physics?
Yeah. So if we were to play the game right now, you'll notice that everything is very static. This cube and this plane just stay in place, but that's not very interesting. So we mentioned that kind of this cube and this plane have colliders attached to them, but you notice when we played the game, the collision didn't really do anything. Like, the cube didn't realize, oh, I'm inside this plane, and pop out or anything. It just stayed in place. And that's because we've attached colliders, but we haven't attached another component that tells it to use physics. So we need to attach what's called a rigid body to this cube, for example. So you can do that by, you come down to here to add component, and either you can find it in this hierarchy here, so you can go to physics and then find rigid body, or you can just type in rigid body. And we want the rigid body, not the rigid body 2D. Let's have this rigid body. If we were to play the game now, then all being well, it should just fall down and then land on the plane. So yeah, a rigid body is a component that says, I want this object to use physics. I want it to be influenced by things like gravity and colliders. So there's a few properties that control how this works. The mass, if you change this, then if you had objects kind of flying into each other, if I had a very, very high mass object and a very low mass object, then, or a very heavy and a very light object, then the heavy one will keep moving and the light one will get bopped out of the way. So
mass is to preserve momentum.
Yeah. So where possible, try to keep this mass in kilogram units. So I think the convention for Unity is that one Unity unit, when we come here to position, one Unity unit is 1 meter by convention. So if I move this one Unity unit to the left, that corresponds to 1 meter by convention. And the same is true of mass. If I say 1, I mean 1 kilogram. You can tweak this to different values if you want, but the way Unity's kind of physics engine works in the background, it works best if you keep the kind of units to kilograms for this. The drag will influence how much the object kind of slows down when influenced by physics. So I believe this is like, I'm actually not sure what the units of this is, but for example, if we were to put the cube a bit higher here and let it fall, that's quite realistic.
I mean, if you make 2 and do one with drag and one with
Yeah, I'll make 2 then. To duplicate an object in Unity, you can click it and then press Control D. So Control D duplicates. For this one, I'll give it a drag of like 20, I guess, and I hope that has it. If I move them slightly further up again. Hope you can notice the difference here. Yeah, okay, that's very noticeable. So this cube has the drag of 20 applied to it. So what drag does is, if you've got a linear force being applied to an object, so this is a force making the whole object move, drag will dampen that force and slow it down. By default in Unity, gravity is 9.81 acting downwards, which is roughly the same as the real world, or Earth. Other planets are of course less gravity than that, or more, but for Earth it's 9.81 meters per second squared acting downwards. The angular drag, on the other hand, is how much dampening is applied to an object acting rotationally. So if I had an object spinning through the air and it had no angular drag, it would keep on spinning at the same speed as it was before. But if this angular drag was really high, like 5 or 10 or something, then the spinning would slow down. There's also a button here for using gravity, so if I were to leave the first cube with no drag using gravity, and the second one, I'll turn the drag to 0, but I'll use gravity off. If we play the game, it'll stay in place. There's no forces acting upon this object now. I'll use gravity back on. This next one is kinematic, is a little bit more complex. So a rigid body with is kinematic turned off says that I want this object to automatically have forces applied to it by Unity. So, if this cube is in the air, gravity will act upon it. If this cube is kind of, it could be on the floor and another cube, you have to kind of imagine this, but if another cube was moving in during gameplay and kind of moved into this cube, if is kinematic is turned off, then this cube would get hit out of the way. However, if is kinematic is turned on, then even if use gravity is turned on and stuff, this object will still not move. That's because is kinematic is saying, I don't want physics to automatically be applied to this object, but I want changes made to this object to influence other physics-enabled objects. So is kinematic is usually turned on if you're scripting the movement manually. So if I was directly controlling the position of this cube in a C# script, and I wanted it to push other objects out of the way, so other physics-enabled non-kinematic objects out of the way, I would have the is kinematic box ticked, and then I would do my movement. If you don't have is kinematic ticked and you move things around, I need to remember exactly how this works, but the physics gets weird with it. Sometimes it doesn't work how you would like it to. Sometimes you'll get things clipping through other objects, and it's kind of very annoying. So the rule here is, if you have something that you are scripting manually, you're modifying its position and rotation and scale, and you want it to, bop other physics objects out of the way, then just tick is kinetic. The interpolate option here is kind of how Unity calculates the physics in the background. So normally you can use this as none, but I need to remember exactly how this works as well. Interpolate.
So interpolate.
Yeah.
Interpolate is usually for a bullet, so for fast traveling objects. So when each frame, if you have a bullet and it's going really fast, obviously it's only doing it at like a certain frame rate, and if one frame it's on one side of the wall, and the next frame it thinks it's going to jump to the other side of the wall, it will do that without interpolate. But with interpolate, it will know that there's something in between those frames, and then it will stop where it needs to on the wall.
That's right.
And then extrapolate, on the other hand, it will take the current velocity, and it will try and guess ahead where it thinks it's going to be in the next frame, and then it will then try to not push itself through the wall.
Yep.
So interpolate is in between two fixed points that we know, and extrapolate is guessing where it's going to be in the future.
Thank you for that. Yeah, so that's how the interpolate option works. Collision detection. I don't think I've ever modified this myself. Do you have any insight into how this works exactly?
So basically, this is how I think about it like this, right? The very top discrete has the least amount of steps that it goes through to figure out if something's collided, and the further you go down, the more steps it takes in order to check if something's collided. I mean, I kind of know exactly how it works, but I need a diagram to explain it. But basically, the further you go down, the more realistic the collisions, but also the slower the physics, or the more intensive the physics needs to be.
Okay, so this is a sort of a precision thing?
Yeah.
Okay. Yeah, as I say, I don't think I've ever modified that myself. And we go into the constraint section. So this is useful if you have things like, if you imagine if you had a seesaw, for example, and you want physics to be applied to it, but you want to constrain some of the axes. So for a seesaw, you wouldn't want it to rotate along two of its axes. For example, it only rotates along, for example, let's say the x-axis. Around the y-axis, it won't rotate, and around the z-axis, it shouldn't rotate. It's only the x. What you can do is you can freeze the rotation along y and z, and then when physics is calculated for this object, it will only rotate around x where necessary. And the same is true of position. Say if you had a moving platform that you only want to move up and down, and you don't want it to get hit out of the way sideways, but for whatever reason, you want it to be physics enabled on the y-axis. Say if a character jumps on it, you want it to kind of fall quicker or something. Then you can turn off, or you can freeze the position on the x and z axes and only allow physics to be applied on the y-axis. And then I think info is just giving you more information about this object, so that will probably be useful if you're in the game mode or play mode and you want to see exactly the properties of the physics object at some moment in time. So if I turn is kinematic off, I think the way I'll do it is I'll just play the game and then I'll immediately pause, hopefully. Yeah, so at this instantaneous moment, the speed of this is 5.88 meters per second. The velocity is minus 5.8 because, this is falling exactly downwards. Velocity is speed and direction. So minus means it's acting downwards on the y-axis. And there's a bunch of other stuff here. The angular velocity is 0 because it's not rotating, for example, and it's got information about the center of mass of the object, which is quite useful. I'll turn that off now. Yeah, so that's basic physics. Any questions so far?
I just want to bring up a point about constraints.
Yep.
So if you can make a ramp real quick.
Sure.
Like just rotate the floor or something.
Oh yeah. Okay. I think I can just that. That's scale. Okay, fine. Whee.
And then if you make a sphere.
Make a sphere. So I go to game object, 3D object, sphere.
And then if you add the rigid body to that.
I'll just make sure it's. Do you want it like at the top of the ramp, I guess, somewhere like here. And yeah, we'll add a rigid body. Boop.
So then if we play that, as we would expect, the sphere would roll down the hill.
So do the cubes.
Yeah.
Yeah.
However, if we constrain the rotation
On the sphere.
of the sphere,
would that be along the z-axis?
I think Z, yeah.
So, just to show you here, the x-axis is red, the y-axis is green, and the z-axis is blue on here. So it will no longer rotate kind of this way. And I think you're trying to say it's not going to roll down the hill, right?
Yeah. So now it's not going to roll down the hill.
Yeah.
So.
Yeah.
If things go weird like that, you may want to look at your constraints. I've had it a couple times where stuff's gone wrong.
Okay, yep, thank you. I'll turn that off now. I mean, I could also show you things like if you freeze the... I think the same will happen if you freeze the X position here. Yeah, it's just not going to roll because it can't move along the X-axis. Yeah, so that's basic physics. Any questions so far?
So if we go back to the plane
Yep.
for a second. So this has a mesh collider on it, and there's an option that says convex there. So if you add a rigid body now to the plane,
To the plane. Okay.
it will probably complain at some point saying you can't have a rigid body with a non-convex mesh collider.
Yeah, possibly. If we play it, maybe it will. There we are. So if we go into if you have errors that turn up in your game, they turn up here. So red is errors, yellow is warnings, and white is disinformation. We got a red one because it's an error. Non-convex mesh collider with non-kinematic rigid body is no longer supported since Unity 5.
So basically, if you just take any mesh for a collider, it's gonna like it could have really like random shapes, and obviously the physics engine doesn't want to waste a bunch of time calculating collisions and stuff with those random shapes. So convex basically simplifies the mesh. It's not very good on this plane because it's basically flat, but
Yeah, I'm just thinking. I don't think there's an object in here that is concave. That's a shame.
Yeah. Basically, if you have like a loop, like a circle with the middle missing,
I can do
and you have a non-convex collider.
Let's get a MS
Okay,
Paint.
Paint.
We'll show an example. So if you had a mesh that looked like this, I don't know why you would have this. If you don't have the convex option turned on, then it is going to try and match up exactly to this mesh. So your mesh collider, your points will look like this. And it's going to do a straight line between all of those. So it's going to say, here is your mesh. Ooh, here's your collider, sorry. Sorry for my very dodgy MS Paint drawing there. If you have convex turned on, however, it's going to try and form a shell around this. So these lines are going to be exactly the same, because those were already straight lines. But then when you get here, it has to turn back on itself. Instead, a convex is going to do this. And that, in behind the scenes, collision for that is far simpler. I'll leave paint up in case we need to do more demonstrations in the future.
Yes, I think that's everything for basic physics.
Yeah, I think so.
I mean, I guess we can, if you make the plane flat again.
Yeah, if I can go to here and go reset.
We can do some other simple like physics components. So if you click on a random object,
we'll go to this cube
or something, and then if you add the component, I think it's constant force.
Yeah. Constant force.
So then this one you can like add a force just all the time, like every frame it'll just add that force. So if you like make it like plus 9.81.
Oh, if we do 9.81 on the Y and then play it.
This will then go against gravity.
Yeah. On our rigid body, you still see use gravities turned on.
So gravity is minus 9.81 and this is plus. So
I still have a rigid body on the plane. Yeah. Go to the plane and take the rigid body off the plane. Ooh, not reset. Remove component. We'll do that again. Yeah. So this cube has the constant force downwards from the rigid body's use gravity of minus 9.81, and a constant force upwards that we set on the constant force component of 9.81 upwards, so it's cancelled out to 0. So
if we turn off use gravity on that cube, we'll then see it fly up into the air.
Yep.
There we go.
My people need me.
So then you can do any... I'm not sure what relative force does. I'm guessing that's relative to the parent.
I think so.
If you hover over names of stuff, it usually tells you what it...
Force applied locally. So
yes,
that would be
based on the parent.
That is force applied globally, so that's just, as we see, global. That will ignore the parent. So it's really nice to show off torque here as well. So torque is a rotational force. So when we were saying earlier about stuff like this angular drag, the torque is slowed down by angular drag. So if we were to give it a constant torque around the y-axis of, I don't know what the best values to use here are. Let's say 10, and if that's too fast, then oops. Oh, I still have the... Okay, you saw it rotating, but I forgot to turn that. Right. Well, use gravity's off, and there's no force on the Y now. It'll just spin in place. But if we were to turn the angular drag up to something... 1 is probably going to be quite ridiculous, but hopefully... Maybe not then.
Well, the issue is you're adding the force every frame. So
yeah, if you're adding the... Oh, okay, yeah, good point.
Keep getting faster.
Yeah, as well as the angular drag doesn't have enough. If you turn it at this... I wonder if this would slow it down. Yeah, okay, if you give it like 1,000,000, then it's enough drag to slow it down.
So, as you can tell, the drag, the values are pretty much a guess.
Yeah. With drag, I normally just... Sorry, go on.
I just randomly guess for the drag.
I feel as though a lot of game making in this manner is tweaking values until it feels right. Especially when you get to stuff like the gravity, as we said, was 9.81 meters per second squared downwards. But when it comes to jump mechanics and platformers, actually, as it turns out, a gravity of 9.81 feels really floaty. So a lot of developers have the gravity as 9.81 when you're on the up arc, when you're jumping up, but they turn the gravity for that object up when you're falling down. It feels a lot more weighty and a lot more normal in a game setting. So a lot of these figures, the realistic physics actually isn't what you want for a game to feel good. So just to kind of tweak these values around to get something that feels good rather than something that is physics accurate. Unless physics accuracy is what you're going for your game, then yeah.
I have
Hello.
a question.
Go ahead, sir.
Can you change the gravity?
You can. That is, if I remember right, if you go to, is it Edit Project Settings? One of the tabs here is Physics. So, there's actually a lot more useful things here. We haven't covered all of basic physics. My mistake. So, the gravity is the first thing here. So, as we said, it's 0, minus 9.81, 0. But if we change this to plus 9.81, and then play the game, I hope it moves this out of the way. Or it doesn't. Well, let me put the project settings here, I'll dock that, play it again. The things that had physics applied to them will just fly up on the air. So they had use gravity, non-kinematic rigid bodies. So they flew into the air. There's some other things that are kind of around here. So, physics materials, of course. We'll do this in a second. We've talked about collisions so far. So I suppose we can talk about this little thing here.
I mean, I think we should. We should do like the physics materials.
You want to do physics materials then? Okay.
A lot of that stuff is pretty complex. So.
Yeah. Okay. I'll put the gravity back to minus 9.81. So physics materials are kind of a way to modify the physics properties of an object. So you create physics materials by going to the project window. If you right click and go to create, I have to find it down here. It's near the bottom. Physics material. I hate the naming difference between physics material and physics material 2D, but that's neither here nor there. We can call this something like, if we say bouncy, I'm going to make a physics material that's bouncy. We have these properties to work with. So the dynamic friction on an object is, I don't know how you explain this. It's kind of the friction applied if something is rubbing against something else. So if a cube is on the floor and something pushes it across the floor, the dynamic friction is the force applied to it because of that contact that slows it down. The static friction, on the other hand, is if I have an object already on the floor and something hits it to hit it out of the way, I think the static friction is kind of the inertia, the thing that stops it from instantaneously moving. Or, for example, if this was rotated again, and the static friction between the cube lying on this surface was quite low, then the cube will slide. There's no static friction. But if it were quite high static friction, then the cube would just stay where it is. I believe that is the difference between these two. And then the bounciness does what it says on the tin. So if we were to turn the bounciness of this physics material to 1, and then go to the plane, and drag this physics material onto the collider, and hit play, what we will hopefully see is the objects will bounce a little bit. So already, just using these inbuilt components, you can create kind of interesting properties about objects. Obviously, there's no user input yet, so the game part will be quite limited, but if you just wanted to do a simple physics simulation in Unity, using these components, you probably could set that up already. I suppose the friction combine and the bounce combine here are to do with the difference between two physics materials, I believe. So this defines how the two physics materials are, the kind of the properties of them are combined to influence this object. So if it's average, it will take, say, the average of the friction between both both materials. Minimum will take the lowest, multiply will multiply them both together, and maximum will take the maximum. So if, for example, we had a completely bouncy object and a completely non-bouncy object, but the non-bouncy physics material had the bounce combined set to maximum, I'm fairly sure this means that the object will bounce anyway, because it will take the bouncy object's bounciness. That would be the maximum bounce between those two objects. Is that right?
I think so. I mean,
Yeah.
currently the balls are have a bounciness of 0.
Yeah.
So that's why they bounce that high. So if you just put
That's why it's
bounce
average.
combined to maximum,
We say that's
and then
maximum.
play it, it should bounce much higher. It should be 100%.
Yeah, there we go. So now it's taking the maximum bounciness between the two objects. The bounciness of the default physics material is 0, but the plane is 1, so now they're bouncing. This is the maximum bounce, so a bounciness of 1 is saying that all of the momentum kind of applied downwards gets applied upwards.
That's not entirely true, I don't think.
I think it's meant to be that, but as we see, it's bouncing higher and higher.
It's more than it should be.
Yeah. What this could be is kind of very small errors kind of propagating across every physics time step. I think what's the maximum value of bounciness? I'm pretty sure it's between 0 and 1.
1.
Yeah. Okay.
Yeah, I mean, I wouldn't worry about it.
Yeah.
Like,
I suppose.
perfect
Yeah. Go on. Sorry.
simulations, like you said, aren't the best feel, So, I mean, yeah. Should we move on to interaction with the game now?
Yeah. I suppose I'd just end that part by saying that the physics engine is not 100% accurate to real physics just because it has to calculate physics at kind of a fixed interval, whereas real world physics, of course, happen continuously. I suppose there is a fixed time step of the universe, probably, but it's really tiny, and Unity can't quite manage that. When they bring out a game engine that works in Planck time, let me know. But it's a very good approximation. So that bounciness property is kind of... if you wanted something to bounce, just setting it to 1 would work round about how you'd want it in a real game situation. So, yeah. We'll move on to kind of interacting between things.
Hello.
Oh, hello.
Sorry, just wanted to ask, I've come a bit late. When did this start? How much did I miss?
It started like 3:20.
Yeah.
Okay, so I missed 40 minutes. Oh, wow.
That's, well, I mean, the recording of this will go up online afterwards. We've talked mainly so far about the built-in physics capabilities of Unity, so stuff like...
Okay. It's fine, I'll watch it, thanks.
What, sorry?
It's fine, I'll watch it.
Okay.
Yeah, thanks. So, in a meeting.
That's no problem. We're about to move on to the next topic anyway, which is going to be building on what we've just talked about, but you should be able to follow along. The basics here are just things have colliders, rigid bodies make physics happen to things. The more in-depth explanation will be available on the YouTube. Please like and subscribe. Right.
If you go in proper deep into physics, should you do joints as well? Or is that 2D?
Oh boy, there are joints in 3D. They just scare me. Joshua, do you know a lot about joints?
They're the most powerful.
I mean, I tried using a bunch of joints, but they're very finicky, and it's a lot of editing of settings to like.
Yeah. Okay. I think in the future, doing more complex physics in like a session by itself would be a good idea. So this is just to set you up with the basics. So joints, I think we probably should do tutorials about joints. Probably another time.
For really basic stuff, just like a door that swings around.
Yeah.
It's just plug and play, really. But
I mean, is that really basic? I tried doing a door and it was awful. I could never get it to work.
I think this is probably a case of if you've used it enough times before, then you'll get used to it. But
you just need a really good tutorial, such as one produced by Warwick Game Design.
Oh, lofty praise there. Right, let's move on to some kind of interactivity. So, for this, I assume you mean scripting and doing stuff like input along with the physics?
Yeah.
Okay. Right, yeah, so we're going to move on to scripting now. How fun. Any questions so far about what we've done before we move on? Or any additional questions, rather? Nope. Good. So yeah, move on to scripting. If we want to create a C# script in Unity, we come down to the project view and you right click and then go to create C# script. So C# is the language that Unity scripts are written in. I suppose we have to name our script something, and I don't know what to call it. Let's say physics tutorial. That works for me. If we double click this, when you installed Unity, hopefully it installed Visual Studio or something similar. You can use any IDE or text editor that you want to edit your code, but I'll just use what's built in. Well, not built in, but the thing that comes by default with Unity. I'll make this full screen. Right, so...
Can you zoom in a bit, please?
I can. I don't know if that's too much. Yeah, that's probably fine. Right, so we've created our first script. I'm going to kind of go over what, like, at a very basic level, what some of these words mean, especially if you've never coded before. So, in C#, you have these things called classes, and a class is kind of, I suppose I'd call it similar to a game object conceptually, in that it is a thing that contains other things. The things that a class contains are variables, which are kind of properties of an object, and functions, which are things the object can do. So when we say class, this is just saying it's kind of a thing. I don't know what kind of more in-depth explanation I can give than that at a basic level, but for now, a class is just the thing that's made whenever you create a new C# script for Unity. Above that, you'll see it has these things, these using things. Don't worry about this too much for now. All these are saying is, especially using Unity Engine, is saying we want to use some code specific to Unity. So we say using Unity Engine. Unity Engine is a namespace, and when we say using Unity Engine, well, we're taking some code that Unity provides for us, and we can use that in our own scripts. One of those things is mono behavior. So what's happening here is our class is called physics tutorial. That's the thing I named the script. And here we're saying this physics tutorial class inherits mono behavior. And all that's saying is this physics tutorial class wants to take some things that mono behavior defines. So mono behavior is the base class Unity provides for us for components. So when we're saying this, we're basically saying I'm creating a new component, is the kind of basic explanation of what this is saying. So when we inherit mono behavior, this gives us a few functions to work with. I suppose I shouldn't really call them functions. There is actually a distinction. They're called methods, but the distinction now probably isn't worth worrying about. So I'm probably going to keep interchanging that, and I'm very sorry about that. A method is a collection of functionality. So by default, it defines two of those for us. Start is a method that is called right at the start of the game, before the first frame update. And update is a method.
I would just like to say something real quick.
Yeah, sure, go ahead.
Start is not just on the start of the game. It's when the object is loaded. It's when the thing is loaded.
Yeah. So for everything, yeah, so on.
If you spawn it in during any time during the game, when you spawn it in, start will happen.
Yeah. So start is at when, like, kind of when the object gets created. If this is an object that is in your hierarchy, then that would be at the start of this scene being loaded. But as Joshua says, if things are being created while the game is running, and we'll get on to how to create things while the game's running later. Then start will be called when that object's created. And yeah, update is called every single frame. So a frame is, of course, when the scene is drawn. This void keyword here is just saying that this method doesn't return any values. So when you're coding, you can kind of invoke other functions. So if I had my own function here called void do things, in update I can kind of do this. I can say do things, open and close these parentheses, and put a semicolon. When update is called once a frame, the first thing it does is call this other function. So the first thing it will do is do everything in this do things method. So if I had something here, this is the easiest thing to show you, would be a debug.log. So if we want to print something to the console that we saw here before, give it a second to kind of load. So this console is what logs things like errors, warnings, and log messages. So if I say debug.log and pass in a string, so a string is between two quotes. If I just say, actually no, we'll do hello world, because that is the classic programmer first program. And if we say Control S, what this is in fact going to do is every single frame is going to call the do things method, and that's going to call debug.log hello world. So that's going to print this string to the console. So if I were to give it a second to build the script, go into my project, if I attach it to any of these components here, so we can say the sphere, for example, I drag on that script I just made onto the bottom here, and we see it as a component. So if we were to play the game now, every frame it's going to run that component, that method. It's going to run, first of all it runs update, and then it calls do things. So down here in the console you can see every single frame it's printing hello world to the console.
If you go back to the console real quick.
Oh yeah.
So obviously this is going to spam quite a lot, and in the top right of the console it says how many messages you've got. So right now you've got 999 plus. If you don't want to see every single line, on the top left there's a button called apps. And if there's an exact copy of a message, it will then combine it into a 1 and then give the number on the right. So in this 2700 of hello world.
Yep. There's also this option here, clear on play. So when I played the game, it started logging these messages, and when I stopped the game, they're still here. If I want them to disappear when I start playing the game again, so I will have this clear on play button pressed, which I currently do. If I don't press that, then it's just going to add more messages to this. But usually I want to keep clear on play on, so that the only errors and warnings and log messages in this list are things that happened since I played the game, not from like my last playthrough of the game. Yeah. Yeah, so that's how to kind of call a method. We say it's calling a method, as if your computer's just got like a telephone connection, a landline, but yeah, that's the terminology there.
So if we do basic input now.
Yeah.
So the input's handled by the Unity input system. So you don't have to worry about, whether your user's like on a keyboard, on a controller. Unity handles all that for you, which is very nice, and it does it through the input system. So if we go to the input settings,
yep,
in the editor,
So the input settings are in project settings. We go to edit project settings, but I in fact docked this on this window here, so I already have project settings. Make it a little bit bigger. One of the options is input manager, and there's this big drop down for axes here.
So these are the different inputs you can do. So horizontal and vertical are like is like an axis of like how far. So on controller, it'll be like a joystick, how far the joystick is pressed to the left and up, for example, say. So if you open horizontal,
Yep.
A lot of this stuff you don't need to worry about. This is just giving you like an example of how it's going.
Yeah.
So in this case, horizontal is A and D, so it's using basic WASD input. So when you hold down A, it will move to the left on the horizontal axis.
Yep.
I think the second horizontal there is that the joy.
This is the joystick.
Yeah, so that's the one that's handled by the controller. So it handles both controller and keyboard at the same time. And so yeah, and then horizontal and vertical are axes, so you can do them differently. So you can, they're a value between -1 and 1. I think. Can you set -1 and 1, or is it?
I think it's -1 and 1, yeah.
Default.
So
then,
yeah.
So then those are the horizontal and vertical, and then if we go to fire 1,
Go to fire 1.
this one is mouse button 0, which is left click.
Yep.
And this one is a button, so it's only like on or off. That you don't have a number associated with it. And then fire 2 is mouse 1, which is right click. And then fire 3 is mouse 2, which is pressing the wheel in.
Yep. Middle mouse click.
These buttons should be available to just search online, so you can search up like Unity input mapping, and you'll find the exact names that you need. It's pretty strange that they have like names like this, but it is what it is.
Yeah.
So then now we can. I guess we.
Oh, sorry. I was gonna say I think we'll kind of link one of those kind of things in the description, because kind of finding the right one could be quite annoying. But yeah, there's lists of exactly which names to use for which button mappings. Yeah.
And then finally, jump is the last one we're interested in.
Jump.
Which is on space. So these names don't mean anything right now. They're just a way to identify what has been pressed. So jump might not necessarily mean jump. Jump just means space is being pressed. I'm not going to go into details on the rest of the information here, but
yeah,
you can look it up if you need. You don't really like. If you wanted to include an extra button, just copy the values from another button already assigned, basically.
Yep. If you wanted to add more, you can just increase this number, and it will add another. So if I go 19 rather than 18, it's just going to duplicate the last one on the list, and I can overwrite this with whatever values I want. But I'm just going to leave that at 18, which will delete that last one. Or I think you can right-click one of them and say duplicate array element. So that adds another one underneath it, but I'll undo that. Yeah.
So instead of printing hello world every time, if we only press hello world or do hello world when we press space, for example.
Yeah.
So to interact with the input system, we just type input.
This is the input class.
And then dot.
And then yeah.
Full stop, and then.
So
then we have to find the correct button that we pressed. So we are looking for the jump button because that's space. So if we do get button, yeah, get button.
You'll see it
And
actually auto completes for us a load of options that kind of match that we typed. So we can auto complete these if we want. So not only do we have methods for get button, but we've also got get mouse button, and there's 3 different options here for just get button. So get button will check if a button is currently being held down. Get button down will check if the button was pressed down on this frame. So for the first frame that you press a button, get button down is active, and while it's being held, get button down becomes inactive on the second frame onwards. Get button up will be true if we have just released a key this frame.
So we do get button down because we've just pressed it.
Yep. So get button down is only going to kind of become true on the frame it was pressed.
So then now we give it the string for our button name, which in this case is jump.
Yep.
So then this is gonna say yes or no whether I've just pressed the button. So we need to check whether we have. So we do that with if.
So yeah, we wrap this statement in if, and we put parentheses around it. And then, well, the convention here is you say if, open parentheses, and then you put in some kind of expression that evaluates to either true or false, or yes or no. So in our case, input.get button down evaluates to either true or false, depending on whether this button was just pressed down. Then after the closing parenthesis for the if statement, either you can have a 1-line statement afterwards, and the convention here is to indent it by 1 tab, or you can have a block, so we can open up curly braces, and then everything inside the curly braces gets evaluated in order, so line by line. So I can put that there.
So now yes, we can go back to the Unity editor.
Yep.
And then hit play.
Well, it's got the little swirly mouse cursor. It's currently building that script. So now we can press play once it's finished spinning around. Now I had that attached to one of these cubes, right?
Yeah, so now in the bottom left, it's not saying hello world anymore. Then if you press space,
it can't hello world because I press space. I can actually click this and it brings up the console over the game. So if I focus my window back on the game by clicking it, every time I press space, you'll see the number here goes up. Or if I don't have collapse, you'll see another one appear. So I'll focus back on the scene again. I'll keep pressing space and it will keep adding a hello world. And collapse again. And close that.
So obviously just printed something is not that impressive.
Mm-hmm.
So we want something to happen, in the game.
Yeah.
So if we add like a player.
Yeah, if we add a capsule, I think we'll do. We'll rename this. If we go to right click rename, and I'll just call it player. Let's say a little capsule. I suppose we'll want a rigid body on this, right? So we want them to have physics applied to them. So we want them to fall down from gravity. Yeah?
Yeah, if you just center it as well.
Yeah, I'll go to reset, and then I'll drag it upwards so that it's touching the floor only just.
And if we move our script to the player.
So yeah, I'll delete it off the sphere, and I'll just put it on the player now. So you can actually either drag it in from here, or you can go to add component. You can go down to scripts, and it will bring up your user scripts and a few others. Or you can just type it as normal. So we can just say physics, and it will bring up everything that matches. I've got physics tutorial was our script that we built, or we wrote.
So now you want to move our player around.
Yeah. So as well, go back to the script.
So in this case, we want our player to jump.
Mhm.
So, how do we make it jump? Well, we add a force upwards to our rigid body.
Yep.
So to do that, I mean, I don't know if you want to replace do things.
Yeah, so we'll just get rid of
Or
this.
replace it do things.
We don't need this anymore.
So to add physics, we need to add physics to our rigid body, but currently we don't know where we don't have access to our rigid body because we only know about ourselves in physics tutorial. So to find out the rigid body, we need to use the get component.
So yeah, that's a get component is a method that's available on all mono behavior or mono behaviors and everything that inherits mono behavior. So from within any kind of script that you're writing in Unity, you can just say get component. The syntax of this is you say get component, and then you open up these kind of well, it's a less than greater than sign, but we call them like triangle braces. And what we do here is we pass in the type of thing that we want to get. So we're looking for the rigid body, and the type for that is just the word rigid body. And then we do our open and close parentheses because it's a method call, and then close it off with a semicolon. But currently all that's doing is just saying get component. It's not storing this anywhere. This doesn't magically give us access to the rigid body. It's just saying get component and then not doing anything with it. So we actually need to assign this to a variable. And to do that, I suppose there's two ways of doing this. We can either do this locally right here. So we can say rigid body, and then this is the type. So we can say rigid body and then give it a name. I'm going to just call it RB, and then say equals get component rigid body. So the get component method is returning a rigid body, and then we assign this to a variable, and I've named my variable RB for rigid body of type rigid body. So the syntax is to create a new variable. It's type name, and then you say equals something that kind of returns that same type. The second way of doing this is rather than...
I mean, if we just do everything first...
We'll do everything first and then come back to that. Okay, yeah. Okay, so now we've got access to the rigid body. So we wanted to make our rigid body jump when we press space. Now we have access to the rigid body. What we can do is RB dot. And what this says is, on this rigid body, we want to call a method. So you can just scroll here and find all of the methods which have these little cubes there, and all of the variables which are these little wrenches that are available on the rigid body. We want to add a force, which is actually right here at the top. So I can just double click that and it will say add force, or you can type it. And then this is going to ask us to define what force to add. So I suppose there's multiple ways of doing this. But
I mean, if we just do X, Y, Z.
Yeah. So
we want it to go directly upwards. So we don't want any in the X. So
So
if you put 0 in the X.
and then a comma.
And then if you do... And then Y, I mean, if we just put a random number in Y, like put like 10 in Y or
So 10.
something.
Yeah.
And then we don't need anything in the Z, so if you put 0 in there.
And then I'm going to end that statement with a semicolon. So you'll notice here, anytime we kind of do something, you put a semicolon on the end to just tell C#, yeah, I've done writing this line. Then you go to the next line. And we press Control S to save. I keep doing... basically when I'm writing scripts, I press Control S like a maniac so that you don't lose progress. Control S is save, of course. If we go back to Unity now, this capsule has this script attached to it. When we press space, all being well... okay, that didn't jump. Do I need to give it more force?
So basically, our force is not good. It's too small to overcome gravity. So if we make it like 10,000 or something.
This is gonna like make it clip into the air really fast.
I think I know what it is. I think you want an impulse, don't you? For your force.
Yeah, there are different ways of applying force, so... You're right,
That way it
Kofi,
just
but we'll get onto that.
Student becomes the master.
Yeah,
Who
student
would
is
have
the
thought?
master. Yeah, so you give it like a much bigger force, and it just flies into the air.
So now it just disappears. So now we have to go back and we have to change our number again, and that's really not good. So this is where, if you go to another component in the editor,
Yeah. So if we look at...
So this
for
is
example,
where-
everybody.
they have their variables that you can access in the editor. If you look at our physics tutorial, we have nothing. So wouldn't it be nice if we could just change the
Yeah.
force of how much we go up on the fly, rather than go back to the code and change it?
Rather than having to go code, change this to like 1,000, and then save it, and then come back here, and then wait for it to build, and then press play, and then watch it fail, and then go back to the code, and then change the number. If I... Yeah. I'll let you continue.
So outside of the update, if we make a new variable,
So I'm going to put this variable right at the top after the curly brace that opens up the class. So if we say...
so to make it appear in the editor mode, we need to make it public.
So we say public, and that says
So that means
I want this to
open
be
to
visible
everything.
outside. Sorry.
And then if we have a float, which means like a decimal number,
Stands for floating point.
and then we call it like jump power or something.
This is the name of the variable, so it's like what we did here before, except when we were doing it here, we didn't have to specify like public. So it's the access modifier, we call it. So public in our case, we want it to be visible. Then the type, which is float, which is just a decimal number, and we call it so jump force. That's the name of our variable.
So as you can see, there's a capital in the center of the name. That's this format's called camel case.
Yep.
And if you do it in camel case in the Unity editor, it will actually split up those words into jump and force.
Yep.
For you automatically.
Don't worry a huge amount about kind of conventions for code, like to begin with. You'll probably mess it up a little bit, but the convention for variable names is that we use this camel case. So the first, if it's like a real word, the first character is lowercase, but every time you start a new word afterwards, you put capitals. That's called camel case. And then for method names, you start every single new word with a capital. So if I had like void, like before, I had void do stuff or do things, whatever I called it. So, you know, I started both words with a capital. That's the convention for methods. That's just the conventions for C#. Other languages have different conventions, and it's very, very annoying, but we'll stick with this for now, and you'll probably just learn how, you know, which conventions to use.
So now if we replace our 10,000 with jump force.
So rather than having 10,000 there, I'll control and paste that in.
So now we can go back to the editor.
You'll notice here that I didn't actually say this is equal to anything yet. If you do that, then it will kind of by default give it a sensible default value. So for floats, that would be 0. So if you go into the editor here to our player, or over the script to compile, I'll scroll down and you see it here. And it's got a value of 0.
So now, I mean, we've done 10 and we've done 10,000. So, I mean,
Yep.
do you want to go for like 500 or something?
So I say 500. And then I play. It should give us something between those. So it's still very high, but that's more like what we'd want.
I mean, if you turn off maximize on play, you can then edit the value to get a good one.
So there's this button here, maximize on play, that just, when I play the game view... That was interesting. Yeah, as I said, the physics simulation isn't 100% accurate, so what I think happened there is that due to inaccuracies and how it calculates things, when that capsule landed on the floor one time, because it has a rounded bottom, I think it accidentally rotated it slightly and it just careened into one of the other objects. So yeah, as we said, 500 was a bit too much, so actually, rather than changing it here, I think what you want to show is, if I play the game, I turned maximize on play off. If if I jump here, it's like too high. If I change this down
Can
to...
I actually turn off the bounciness?
yeah, I'm gonna okay. Where's our plane? I'm going to turn the material to none. I'll say that. Oh, I could have done that now, couldn't I? Oh well. Right, now we've into transfer. So if I jump, it's just gonna go wee and then land. If we want to tweak this here, we can tweak it in place while it's playing the game. So it's still playing. I can kind of get a feel for it, get a value that I think feels right. So maybe that's too high, but maybe like 325 is what I want. Yeah, so you can tweak properties here as you want. The only thing to kind of keep in mind here is that kind of typically things that you tweak in the inspector here won't stay tweaked when you stop playing. So if I stop playing here, that goes back to 500. That's what it was before I started playing. So just keep that in mind. It's so that you can test things out without being destructive, because if you made like 100 tiny changes and then it saved those after you were playing, going back and changing them all will be really annoying. But the double-edged sword of that is that if you made a good change, one that you want to keep, you need to remember what changes you made to change, like, to tweak them after it stopped playing. If that makes sense. And yeah, just for the add force in particular, as Kofi was saying, there's actually different modes of this. So we can add a fourth kind of fourth parameter to the add force method. What we were doing was what is called force mode.force, which just adds kind of an instantaneous force of whatever values the x, y, and z that we passed here were. But instead of that, we can say force mode.impulse, which instead instantaneously modifies the velocity. If you imagine, force is kind of what happens when I'm like, say if I were pushing an object along smoothly, maybe like if I were pushing a wheelbarrow, I am applying a constant force to that object. So force mode.force is probably what you would want to use if you're applying a force every physics time step. Force mode.impulse is if you imagine if I have a hammer and I hit something off the table, it's applying a very quick, immediate impulse to the object instead. So this is like, for an impulse, 325 is going to be too much, but 10 is probably better for an impulse. So 10 is going to apply an impulse of 10 meters per second upwards. And even 10 is too high there, so we'll want to tweak this down to something like 5. When it comes to physics, as we said, kind of tweaking all of these properties is what you're going to have to kind of do to tweak it until it feels right. So if force mode, if having no force mode there isn't working right, try changing the force mode. Ooh, that's my paint diagram again. And you know, you'll get something that kind of feels better. Any questions so far? Are we going too fast or too slow, or?
I'm following.
Okay, good.
I mean, should we? So if you play again.
Yep. Do you want me to select? I'll select the player.
And then if you just hit space a bunch of times. So as you can see, it flies off, and that may not be exactly what you want it to do.
We didn't have any condition to check if it's on the floor before we allowed him to jump. I don't know who I want to name or play or something. He's called John now.
So if we only want it to jump when it's on the floor.
Yeah.
So how do we know if it's on the floor? Well, the most simplest way, I mean, if we just assume that it starts on the floor.
Yep.
And then when we jump, we're off the floor.
Yep.
Then, so if we make a new variable outside of update.
Yeah. I'm assuming we don't want this one to be very visible in the inspector. So the opposite of public is private. Private. I suppose you're going to want to make a boolean here, right? So a boolean is a value that's either true or false. So the word for that is bool. I'm going to say grounded. And as you're saying, we'll assume that we're on the ground to begin with. So we're basically saying when this script gets created, or like, you know, when we start playing, the default value of grounded is true, so we are grounded to start off with.
So in our if statement, we can say we need to press space and we need to be grounded.
Yep.
So to use and, you need to use the ampersand.
Yes. So the way this works is you say, you know, if input.getButtonDown jump, you do double ampersand, and we say and grounded. So this is saying, if you've done any kind of formal logic, then this will kind of be familiar to you. We're basically saying if this and this. So this, everything that's in between the if braces needs to evaluate to a single Boolean value. And using the ampersand here, it's basically saying, you know, if this and this is true, then this whole statement's true, else it's false. So if we only had, you know, get button down jump is true, but grounded was false, then the if statement evaluates false. This is basically checking, you know, we have jump, press down, and we're grounded.
Does this grounded thing have a bit of, like, what's it called? Basically, you don't want it to be able to not jump if you're 0.0001 pixels above the ground due to a rounding error.
Yeah, I suppose, I think we'll
get to that in a minute.
Yeah, we'll move on to how to handle, how to detect if it's grounded again. We're making the assumption here that it is grounded to begin with, but that's good enough for us. That's for something you probably want to make sure of when you build a game yourself, but we'll kind of move on to that. So what we're going to do is, you know, if we press jump and we are currently grounded, we'll let you apply this force. But we're also going to say grounded is false.
Because now you've jumped.
We're no longer grounded. So what this is going to let us do is, if we go and play it again, all being well, I press space a bunch of times, it's only going to let us jump once. So before we had the problem in the air, it was still letting us jump, now it won't. But now we have the new problem of we can't jump once we've landed.
So now the question is how do we know we've landed?
Yeah.
Well, this is going to be very arbitrary, but we're just going to say when we've collided with something, we're going to assume that we've hit the ground and we can jump again.
Yeah.
So that means how do we know that we've hit something?
Yep.
So we can use a physics method called onCollision.
And we'll see, as before, it's auto-completing a load of them.
Specifically onCollision enter.
Yeah.
So that means when we hit something, this is going to run.
Yep.
So no matter what we hit, whether it be another box in our scene, whether it be the ground, anything at all, this function will run.
For now, we're just going to assume that it's the ground we're hitting.
Yeah, so when we collide with something, we can jump again. So how do we make sure we can jump again? Well, we set grounded to true.
Yeah. So remember before I said this mono behavior gives us a load of things? Well, this method is one of them. So if we write this, then it means, yeah, we are detecting collision events. OnCollision enter is when... okay, how? So this is similar to the kind of get button down situation we had. OnCollision enter is called on the frame that a collision occurs. OnCollision stay is called if a collision is still happening. So that was similar to get button. And on collision exit happens when a collision stops existing. So alternatively here, we could in fact say on collision exit, we set grounded to false. But this is good enough for us now. So if we go back in here, if I press space, I will jump. I've landed. If I press space again, when this capsule touches the plane, it generates this collision event and runs this code. So we're able to jump again. And then, of course, when we press jump again, it sets grounded to false, and so on and so forth. So I can't just hammer the jump button while I'm in the air.
So now we can just jump, but that's not very interesting. So let's give it some more directionality. So let's try moving around the floor. So if you could remember, those axis buttons, which were horizontal and vertical. So again, if we do the input, Unity input again,
yep,
and then if we do not a button this time, but if we do an axis,
so
get axis, and then the name.
So if we say horizontal, you do need to make sure these names match up exactly to what you wrote in the input manager, or it just won't do anything. I think it will complain at you if you type it wrong as well.
This here will give us a value between -1 and 1. So then, if we save that into a variable like we did with our rigid body,
float, let's say float x, because this is like the horizontal x-axis movement, and we can also do the same.
And if we do same with y,
you can say float y equals input get axis, get axis.
Actually, if we call it z, not y.
Oh, sorry, yeah, call it Z. We're moving across the XZ plane up as Y in Unity.
So now we need to again apply force to our rigid body. So, however, we've only saved our rigid body in the if statement, but we also need to now access it outside of that. So if we make our rigid body outside of our update, we can access it everywhere.
So yeah,
undergrounded if we had our rigid body up there.
Yep. So generally speaking, with Unity components, if you're going to be using them every single frame, it's best not to go and get the component every single update loop, because this get component method is quite expensive.
Very heavy.
It takes a lot of resources to go find this component. So it's far better if you do this kind of at the start. So again, if I were to say private rigid body, we'll call it RB again. So here we can't just say get component rigid body kind of here. We in fact need to do this in the start method. Yeah, so we say, RB equals, and then we can just copy paste this over, or cut, paste, and get rid of this line. So now, this RB variable is available everywhere in the script. So I can use it in the start method, I can use it in the update method, I can use it in any user-defined methods, I can use it wherever I want. We're only grabbing it once, and now it's available everywhere. So right, back to update.
So if we now do another add force.
Yep. So if we're to say
the rigid body.
Add force, and here instead we're going to say x to give this force this x across the x-axis, 0 on the y because that's handled by the jumping, and then z on the z-axis. And for now, we'll just use the normal force mode. Yeah.
Yep. However, this is going to be between 1 and -1, which is very low. So if we add a new variable, which would be our move force,
I'll put that underneath the jump force. So,
and if we make this public, so we can edit it again.
Yeah.
In the editor.
So what we can do, I'm going to copy this. So we can do some maths here, in fact. So we can basically say either we can say x equals input.x-axis horizontal times move force, or we can just say add force x times move force here. So that kind of just multiplies this value by whatever we define the move force over here in the editor. So if I click on my player, you'll see move forces here. And if we gave this, I don't know, that 10, probably going to be quite high, but we'll see what this is like for now. So if we remembered in the input, the WASD keys were assigned to the horizontal and vertical axes. So I'm going to press A. It's gonna apply the force horizontally, and 10 was quite high, but it's fallen off now, so there's no redeeming that. I'm going to have to restart the game. I'll just go to player. I'll set that down to like 5. So that's me applying the force left and right, and
so
then vertical left right here.
It's tipped over. We don't want it to tip over. So this is where we can constrain our rigid body to make sure it doesn't tip.
So see, back to the constraints on the rigid body. We don't want it to rotate along the y-axis. So we're going to freeze rotation on y.
No, it's X and Z, I think.
Oh, sorry. Yeah, you're right. Oop. One way around. Yeah, sorry. The X and Z. It will stay upright. Oh, I still went too fast. Let me just play it again. So now I can move kind of forward and backwards using do and S, and then A and D to move sideways. So, you know, we've got the kind of the beginnings of a game here. We've got some interactivity. You know, I can knock things off the edge, and you can see how if we keep going with this, then we'll have something resembling a game.
So the camera is in a fixed position. We don't want it to be in a fixed position. We want it to follow the player.
Yeah.
So if we add the camera to the player.
So for example, if we say last week we talked about parenting objects. So now this main camera is a child of the player object. So when we move the player around, the camera moves with it. So now if we were to play the game. Now you saw there, in fact, we haven't locked rotation around the y-axis. So when I collided with this cube, our capsule actually spun round. You can see it now probably, yeah. So that shows that we're still spinning around on the y-axis, but that's as we intended. But the main thing there was the camera moved along with the player. If we wanted to, we could just like move this camera around, so it's like a more of a top-down view. Something like that. Obviously, it's incredibly annoying how.
So if we lock the capsule's Y rotation.
Yep. If we play it again, then it's going to be a lot more sensible. We'll just go bonk. And now the capsule is not rotating around the Y, so.
However, we're still kind of in a fixed camera position.
Yep.
So I mean, how are we going to deal with that? Let's just say we move the mouse left and right, and it rotates the camera around the player.
Yeah.
So how do we do that? Well, if we go back to our code.
Yep.
And in the update again.
Yep. So we're on the update method.
again, we're gonna use the input system that Unity provides for us. I think, right?
Yeah. So
if we do the input again and then specifically ask for a mouse property.
Yeah. So you want to say input dot get mouse.
Get mouse.
So we got mouse button. I suppose you want mouse button.
Hang on. Wait, hold on a second.
Yeah, just want a couple of minutes to think.
What are you after?
Oh, it's mouse X, mouse Y on the get axis, I'm pretty sure.
Okay. Oh, you want to do the mouse movement rather than the mouse clicks, right? Yeah. So,
Get axis.
there's in fact there were two that we didn't go into detail with, but there's mouse X and mouse Y. So mouse X is how much you're moving your mouse left and right. Mouse Y is how much you're moving it up and down.
It has a space between mouse.
What is
X,
it?
by the way.
Okay. So we can do the same as we did before. So we can say float mouse X equals, and then we can say, you know, the same mouse
That's
Y.
the stream for clouds. Okay, never mind.
Ooh.
It came back now.
It's back? Right, good.
So then, now we've locked our rigid body rotation so it doesn't get influenced by physics. We have to directly change the rotation ourselves. So we do this using the transform. So luckily, the transform is cached by the mono behavior itself, so we don't have to get component transform.
So if you
we
remember,
can just type transform.
if we were to go on the player, as I mentioned before, every single game object in Unity has this transform component, but every single mono behavior can also just get the transform for free. We don't need to do this like we did with the rigid body here. We can just say transform, and we can do stuff to it. We just have this available.
So then we can take the rotation.
Yep. So you want to say dot rotation or
let's just do transform dot rotate.
yeah. I was thinking that's probably easier, isn't it? So this is just a method that says, you know, rotate this transform. Simple.
And then if we just want to rotate around the Y.
Yep.
So if we do
So
zero
comma
mouse X.
yeah, well, you want to say mouse X, yeah. I don't know why I did a variable for mouse Y, but it's there now, and then 0. So this is going to say rotate nothing around the x-axis, rotate this much around the y-axis. So basically, when I move my mouse left and right, it's going to rotate around the y-axis, which is going to kind of move the camera left and right. Probably a little bit counterintuitive, having the mouse X input rotate the y-axis of this object, but it makes sense.
If we also make a sensitivity variable as well.
So if we were to say debug float, something like this. So we'll say mouse X times mouse sensitivity. Wait for it to compile my script. Kind of sometimes blinks some of these windows when it's compiling scripts. That's how you kind of know it's done. This is mouse sensitivity. We'll say 5 maybe. We'll take a guess on the initial value, and if it's too high or too low, we'll change it. If we were to go into the scene now, when I move my mouse left and right, the camera rotates around this. So oh god, yeah. Still very slippery movement. what you won't be able to see here, but what you'd be able to appreciate if you were playing the game is, in fact, if I rotate 90 degrees here, if I press up, it goes up globally. It's not relative to the camera. So these kind of these add force methods here are acting globally rather than, say, locally relative to the camera. I suppose that's the next thing that we'll want to fix, right?
Yeah, so there's actually a really nice way to do this.
Yep.
So if you make so add force is looking for a vector, which basically is just a number of float values, in this case 3. So if we make a new vector 3, because we have 3 values, before we add our movement force.
Do you want me to do that up here?
Yeah.
So say vector 3 move equals new vector 3.
We just put our x and z in there.
So yeah, if we just say x, 0, comma z, z.
And then what's nice about these vectors is instead of multiplying each thing independently, we could multiply it all at once by our move force.
Yep. So this just says each individual component here, multiply those by move force. So this is x times move force, 0 times move force, z times move force. The alternative is doing individuals here like that.
In our add force, we can just replace everything between the brackets with move, and it'll do exactly the same thing.
Yep.
I mean, do you want to show off it?
Yeah, it does the same thing. It does the same thing. Trust me. Yeah, so it does the same thing. So if I were to press like up, down, left, right again, same as before. There we go. But it was still relative to not the camera. It was still relative to the world.
So we need it to be relative to the transform. So if we access the transform again.
Yep. Do you want to do this here, basically?
Yeah. So we make another vector that's like actual move.
Yeah. Let's call it actual move for sure.
So then if we go to our transform again using the transform.
Yep.
And then we have a vector, so we can do transform vector. Transform vector, like. Is that right?
Yeah. Sorry, transform vector.
So there's two things here. There's transform vector and inverse transform vector.
Yep.
One transforms it from local to global, and the other does it the other way around.
Yeah.
You don't have to remember it because luckily the Visual Studio, if you hover over the name, so if you hover over transform vector, it will say, so this transforms from local to world. So we don't want this, we want the other way around. So
the other one is that inverse transform vector, which says transforms the vector from world space to local space.
To local. So then now if we say do this on our move.
Yeah. So we're passing this move variable into this method.
That'll do all of the funky calculations.
Yep.
For us, so we don't have to worry about any of the rotations.
Yeah.
Or anything.
And then
now we can just use actual move.
Fingers crossed. This should all work for us. So now I'm going to rotate 90 degrees, and I'm going to press W, so up, and it's going to go the wrong direction. I can fix that. I can in fact just say float x equals minus input horizontal. No, wrong one. Sorry. Sorry. Change the vertical.
Wait, you sure that wasn't because I got it inverse transform versus
Hang on a minute. No, left and right are wrong as well. No, I think you're right with. Hang on a minute. If I change this and then. If I change those and it works, then sure. Okay, maybe it was the... Yeah, this is working as I want it to. Right, okay. It's transform vector then, so... No, yeah, sorry, that is the one you want, isn't it? Because you want to say this move is in local space, and then you want to transform it to world space. Yeah, it's transform vector, sorry. Yeah. So now, I suppose you can't feel this for yourself, because you're not playing the game, but... now I'm pressing W to go forward, and it's going forward. I'm pressing S to go back, and it's going back, and A and D go left, relative to the camera. So now it's actually playable. Oh! You see my insane parkour skills in Unity tutorial session game.
I mean, does anyone have any questions?
Doesn't look like it.
I mean, what else can we add?
I wanted to get onto stuff like triggers, because they're quite interesting.
Okay, so, I mean, do you want to, like, make your platform really long then?
Yep. Let's say... Oop.
And if you put your character one aside...
The character over here. Sure. You know, I'm gonna change the floor color so I stop getting confused between the cubes and spheres in the floor. So I'm just gonna say I'm gonna make a new material, call it black, and I'll make it black and drag that onto the floor. Now it should be a lot easier to tell the difference between. I should have done that like hours ago. So now I have played the game. It's a little bit more obvious what's the difference between like the floor and the not floor, right?
So, I mean, I guess we can make this into an actual game. So, if we make a cube at the other side of the platform...
do you want me to add a new one?
Yeah, I mean, or you can use a current one.
Yeah, I'll just copy one of them over. Cool. Like that?
If you put it on the floor, make it slightly larger.
Okay.
And then if we say this is our goal is to enter the cube, you know, like so if we make it like slightly transparent, so it looks like we're gonna go inside it.
I'm making a material. So you go right click, create material, and we'll call this goal. So on this albedo here, we can in fact turn the alpha down to something, you know, smaller, but the rendering mode of the standard shader by default is opaque, so we go transparent, and this turns kind of transparent. If we drag it on there, then it's kind of sort of see-through. Yep. We'll probably turn it a bit more. Let's just go. Ooh. Yeah, there we go.
So we want to enter the cube. So I mean, do you want to try entering the cube?
Yeah. So currently, we see this. I actually just bonk into this cube. It's a physics object.
Pushing the cube, that's not very useful. So
instead of that, we want it to be some kind of goal that like we phase into, rather than hit out the way.
If we turn off the the forces action on it.
Yep. So which way do you want me to do that?
So if you turn on is kinematic.
Oh, we're doing it. That's the easiest way, isn't it?
So now it won't have any forces action on it.
That will stop it being bonked out of the way. So if we were to just careen into it, it won't
solves
move.
issue 1. So issue 2 is we can't go into it.
Still can't into
that's an issue with our collision. So if you look at the box collider on the left hand side.
Here's our box collider, and we're selected the goal
There's
here.
an option called is trigger.
So when it comes to colliders, there are 2 types. What we've been working with so far are just, physical colliders, and that says, please don't enter me. Triggers, on the other hand, are, they don't stop objects entering this volume. So for a box collider, this cube, if his trigger is enabled, things can still enter this, and that's useful because we can detect when things enter it. So if we were to play the game now, we'll just avoid these cubes. We can enter into this cube. So it's just a trigger now. It's not doing anything at the moment though, but we are able to enter into this.
So, I mean, the question is, how do we get it to do something? Well, if we make a new script for our goal...
Yep, there we go, create
so if we do it a different way, if we do a different way to make our script, hold on. If you delete that for a second.
Yeah, sure. Delete.
If you go to the goal object...
Yep.
And then, if you click add component at the bottom...
New script. Yeah,
new script. So then... New script, and you can name it something.
I'll name it goal. So create and add.
So then that adds it automatically.
Oh, sorry. Yeah. So this adds it automatically to this object, and then creates the script here. Just as a small note before this gets out of hand, it's usually bad practice to just add everything to the root assets folder. So it's a good idea to create folders and put like different types of things in here. So usually I'd have something like maybe scripts, and I can drag my scripts into here. Maybe I'd have another one, just let it load, another one called, say, materials, and I can drag all of my materials into there. My, like, rendering materials, I guess. That just makes it a little bit more organized, so, hold on, we'll open up the goal script.
So again, it comes pre-packaged with the start and update. But these ones we don't really care about, because there's a special event method that is called when something enters the collider, which is, so there's a selection of 3 again, which is trigger.
Yep.
So enter, exit, and stay. So we want it to, when we first go into the goal, so we'll have enter.
So if we double click that, it just auto completes the parameters to the function.
So if we just like debug like goal or something.
You give it an exclamation mark. More fun. So our goal already has that script attached because of how we how we created the script. So all being well, now when you see, so when the game started, this this plane and the goal are actually the floor and the goal are touching, so it already gave us one. I'm gonna uncollapse that so it's easier to see, but it already gave us a goal message. If we move our player into it very slowly, it makes another goal. You'll see it down here. Another goal debug message. As we move around inside the cube, it doesn't generate any more. We actually have to exit fully. So even if we're just like only just in it like this, it still doesn't generate another goal message because we used on trigger enter. We need to exit it and then enter again, and it will generate another goal message. Yeah.
So we need to differentiate between the floor and the player. So there's 2 ways of doing this. So currently our player's named player. So if we go back to our code. So we need to figure out what has entered us. So that's information's in the collider.
Yep.
So the collider is the component of the collider that's entered. So in the player it will be the capsule collider, for example.
This collider would be this one here. If it were, one of these cubes, it would be this box collider. But for our use case, it's the player's capsule collider, and it's the plane's mesh collider, which is a problem.
So we need to figure out the name of this collider, or the object that's collided with us. So if we just do other.
So this is the name of the collider. It's passed into this method.
The name is attached to the game object, so we can do that by just asking for the game object. Every component knows what game object they're attached to,
What was there?
and you just use the game object. And then the game object knows its name, so we can just ask it for its name.
Yep.
So then we're gonna compare that name to player.
So to do a comparison, so this is string comparison. There's two ways of doing this. Either you can say double equals. So if I were to say, we're gonna do an if statement. So if we say if this, then it will do debug.log goal. But because this is a string, I think it has a compare to.
Like, you just do I mean, you can do double equals as
I need
well.
to remember. Yeah.
It's just double equals.
Yeah, I'll just do double equals. No, there is another way to do it. I'll just ignore that. We'll just do double equals.
You can overload operators in C#, so it's not like Java.
Yeah.
So this should work.
Yep.
So now if we play and run.
Just wait for my script to compile and then play. Now at the start of the game, it didn't give us a debug message because the floor is not called player. But all being well, if we go in, then yeah, it gives us a goal message because it's checking the name of the thing that is entering it.
So now we have a way to tell whether our player's gone into the goal. However, in the unlikely scenario that we decide, you know what, I don't like the name player, I'm going to call it the actual name of the player. So like, I don't know, just pick a random name.
Jenny. She's called Jenny now.
Okay. So now it's Jenny. So now if we try it again and play again.
No dice.
Well, now it's not called player, so it's not gonna let us win. So we need a robust way of checking whether the game object is exactly what we want.
Yep.
And this is where tags come in.
So generally speaking, kind of doing a name comparison is something that you probably shouldn't do very often, if at all. Just because of cases like that, which are quite common, where I might decide that this object is called something different. However, as Joshua was saying, there are tags in Unity. So a tag is kind of additional information, additional string information I can give to an object.
So every object can have one tag associated with it.
Yeah.
So in this case, it's untagged. But then if you click on untagged, it'll then bring a drop-down menu.
Yeah.
So these ones are all the ones that are pre-installed.
Yeah.
So in our case, this is our player. So if we set it to the player tag,
Yep.
then you have to do it in the editor. So then the game object from our collider will have a tag. So we can just ask the game object for a tag. And
Yep.
then that's also a string named player.
Yeah.
So
even though our game object is now named Jenny, it's got a tag called player. So now that we're comparing the tag to the string player, it should work just fine. Yeah, so it's giving us our goal messages back. Good. And if you want to use a tag that's not defined here, you just come to add tag, has a list of tags here. You hit this little plus button, and you can name this whatever you want. So if I had a I didn't actually see all the tags that were there, but if we wanted one called enemies, or if we wanted one called floor, or one called walls, then if we were to go back to a game object and do our tag drop down, these are now added there. So if I wanted this to be, if I wanted, for example, the plane, I could say floor. And then in some kind of instance where I didn't want this goal to say something just for the player, but I wanted it to say something for everything that's not the floor, what I could do instead is, say if we were to just have like this cube floating above, so when the game starts, this cube's going to fall on top of, just make sure it's, yeah, this cube's going to fall into the goal immediately. So if we wanted that to generate a message, but not the floor, we can say if other.gameObject.tag not equals, and we do that with this exclamation mark equals, not equals floor. Wait for the script to compile. So because our plane is tagged floor, it should generate one message at the start when the cube falls in, as it did, and then generate more messages when I fly in there as well. But not for when the floor is well, the floor clips into this goal on frame 1, so it didn't generate a message immediately. It was like a half a second or so before it did that. So that's the basics of triggers. So, you know, if you had events that you wanted to fire in your game when an action happens, when someone, say if someone moves through a door and you want like, you want to drop zombies on their head or something, it would be more complicated than this, but you use a trigger, check if it was the player, and then you'd run some code to make the zombies fall on their head or whatever. Any questions so far? Oh yikes, it's like 5 already.
Did you put the previous one on YouTube?
I put the previous session on YouTube, yeah.
It's in the announcements.
Can you send us the channel or the link? I didn't see it.
It's in the announcements post.
Yeah, it should be in the, not the latest one, but the latest big announcements post.
Oh, okay.
Yeah, it is kind of, there was a lot of things in there, so yeah, last week's session is available on YouTube, and then there's the link on there. I can put that in, I'll do that in a second. I'll go find it.
It's in a voice chat now.
Oh, you put that, alright, thanks.
If you go to voice chat, it will be in there.
Yeah, sure. Thank you. Yeah, and I'll try and get every single week's episode. I'll try and get every single week's session up as soon as I can. And I'll link it in the email and in the announcements channel for the next week's events. But I suppose I'll also put it in hash resources. I think it's probably a good place for those as well. I'll do that in a second as well.
So I mean, should we turn this into like a sort of a game thing, like a very basic game?
Yeah, sure.
So now that we have a way to, I mean, do you want to change it back to checking just the player?
Just the player, right.
So now we have a way to check whether the player has entered the goal. Let's have like a way to say, hey, you've won the game. So if we go back to the editor,
yep,
it's going to be very crude for now. But if you make a UI text, so we go to hierarchy.
Yeah, we're gonna very quickly go through UIs. So this is by no means the in-depth UI tutorial.
And then just do text.
We'll do a text. This gives us a canvas, so I'm going to click the 2D button and I'm going to click F to frame select on the canvas, and this gives us like a user interface to work with. We've got this text here, so if we put this, say, like the top right corner, I suppose.
I mean, just put it right in the center, because it's going to be a you win.
Oh, okay, I'll put it right in the center. We'll make it like huge. On that center bit. I'll center it. I'll make it like, okay, let's make it 40.
Just put like you win or something.
Yeah, okay.
So obviously we don't want that displaying all the time. So you can actually turn off certain game objects. So if you scroll to the top, there's a little tick the name. Yep. So currently it's ticked on, which means that it's enabled. And then if you tick it off, it's disabled. So if we disable that for now.
Yep.
And then if we go back to our goal,
Yep. Do you want the
And then
script?
go to the script. Yeah, sorry.
I think you can double click there and it opens the script. Yep.
So then if we make a variable which can be accessed in the editor, which is
Public again.
gonna be our game object for our text.
I'll call it win text.
So when we win, we just need to enable that text. So if we replace our goal debug with just win text enabling it, which is just win text, and then it has a property enabled.
Enabled is a components, I think, isn't it? So
Okay, yeah, I think it's set
yeah.
active,
So if
actually.
we do wintext.set set active true. What this is going to do is it's going to find this text, this one that we assigned in the inspector back in the Unity editor, and it's going to say tick that active tick box for us. So to start off with,
So now,
it's unticked.
on our goal object, there's a little box that says win text. So now we can drag our text object into that section.
So this text object in the hierarchy, we just click and drag that into this little box.
So then link it together.
Then if
So
we
now-
play the game, there's no text in the middle of the screen. And if we were to hit the goal, I picked a really bad color, but yep, you win.
There we go, you win.
So here is like the world's worst game. You move into the little cube, and it says you win. Let's go back to here. So yeah. Any questions so far? If you're wondering about the kind of UI stuff, that's something we can go into more detail about in kind of a later.
At the end of the session, can you post the code somewhere?
Oh, you want to post this code on like a GitHub or?
Just like dump it in Discord.
Oh yeah, sure. I'll do that now actually. Just the whole goal.
When it's finished, like at the end of the session.
Oh, okay, yeah, I'll do that after we finish the session then. Sure.
Thanks.
No worries, no worries.
I mean, we don't have that long left. We have 30 minutes.
Yep.
So I mean, if we just had like a simple challenge to the game, let's just have like maybe like 3 cubes.
So you want to do what, sorry?
So if we have 3 cubes along the path that are gonna like horizontally to try and knock the player off.
Oh, sure, if you wanted to do like that kind of thing? Except like...
Yes, if we had make a new script that's like moving all.
A new script. What do you want to call this?
Call it like moving wall or something.
Moving...
Wall.
Oh, sorry. Moving wall. Cool. Let's generate the script and then double click, open it up.
So in the update, we just want to move it back and forth. So do you want to do this with the rigid bodies or do you just want to do it transform?
If we give them kinematic rigid bodies, it would be nice to show that off, I think.
Okay.
So
So do you move that with position or do you move that with rigid body?
you can move it with position, I'm pretty sure. So all these 3 cubes have a rigid body attached to them. I'm going to make those kinematic. So if you multi-select objects and they have the same components attached, you can modify the values of all of them. If it has like this dash here, that means that some of them are ticked and some of them are not. Actually, it doesn't matter because we're going to make these kinematic, so I'm going to tick this box. Go back into the script. So if you want to move these back and forth,
So like if we save our rigid body again, we did.
so if we say again private rigid body. Oh god. Did let's say the autocomplete disappears if you accidentally like hit something else. RB, and then we say RB equals get component rigid body.
So in the update, if we do rigid body for RB,
Yep.
and then if we do move position,
So move position.
is that
Moves the kinematic rigid body towards position. Depends how you want these to move, right?
if you just hang on, if you do rigid body dot position,
Yeah. I think dot position works. Yeah, so dot position.
and then if we do like plus equals,
So plus
So then
equals
that's-
just says take whatever value this has already and then add this new thing to it. And then assign it back to this position.
this needs to be a vector,
Well.
which could be a vector.
So a new vector. Was that Conrad's voice I just heard there? I think hello.
Yep.
Hello. We're currently we're kind of at the tail end of our Unity session right now. So yeah,
Nice.
make a new vector and
Go
then
back to the editor. We need to figure out which direction we want our cubes to move in.
yeah, I'll go back. Yeah, so you want them to move along the Z or
Yeah, so
Move side to
we
side.
want to move on the blue axis, which is Z.
Yeah.
So we don't need it to move along X or Y.
Yep.
And then we need to move along Z. So now we want it to move, back and forth. So the simplest way is to just use like a sine value. So if we do map, is it map F?
it's mathf. So mathf is Unity's maths library. We do mathf. You just want to do sine.
Get the sine function,
So just sine.
and then we need to pass it a value. But
Yep.
if we want to move it back and forth, we can use time to then determine how far it is.
There's in fact a time class, and one of the things it contains is time.time. So this is the time since the game started playing. If we pass this into a sine function, it's basically going to just draw the sine function. So this value is going to fluctuate between -1 and 1. So if we just close this off, it's going to make these cubes go back and forth and back and forth. It's a longer sine wave, so they're actually going to like be faster in the middle of the swing. So if you just play, you should be able to see that, unless it's like gone disastrously, which it. Oh, why?
I mean, do you want to multiply that by a big number?
Sure. Let's just say like times 10. Sure. Although if it's it should do it between 1 and -1. Okay, what might be the problem is we made it kinematic. We might actually have to do transformed opposition rather than rigid body. I'll try that, and if this doesn't work, then I'll start kind of crying.
Well, you haven't attached.
Oh, I didn't attach the script. Alright, attach the script to them, and then alright, I'll change that back to. I do that like way too many times. That happens to all of you too. Don't worry.
Oh my
They
god.
bounced quite hard, didn't they? Yeah, that's because I times it by 10, isn't it?
I mean, if we make a variable called speed or something.
Oh, that's because it's moving it. Okay, what you need to do here is it's moving it by up to 1 meter every single update frame. We need to make that a lot smaller. So to make that, well, it's actually to make it frame rate independent. times that by time.delta time, which is a tiny amount of time between this frame and last frame, I think this will make it a lot less crazy. But I think we will also need a speed variable, as you say. Yeah, there we go. So by multiplying by time.delta time, that is... it means, so rather than moving 1 meter... If for example, we were adding a position of like 1 meter, rather than moving 1 meter every single update frame, it's moving 1 meter every second, roughly. So it's a little bit more difficult now, you know, if we were to stay in place, and these would like bonkers out of the way. But it's quite easy to move around these by just going fast. As Joshua was saying there, we could also add a public float speed. And
also, if you do an offset as well.
Oh, sorry?
If you do an offset as well.
Oh, yeah, so... do you wanna, like a... like that?
Yeah, and if you add that to time.time.
Oh, yeah, so if we say... Oh, to time.time. So if we say math.sign time.time plus offset, and then we also multiply this by speed. If we go back into Unity now, and I've still got all 3 cubes selected here. I suppose we can up the speed to something like 2, maybe? I do want the offset to be...
I mean, if you do the offset different for each one.
Yeah, alright, let's do... Oh, right, yeah, so if we do, like, the offset, the first one is 0. Well, yeah, leave that one as 0. The offset, the second one is, like, 0.5. The offset to the third one is, say, I don't know, 0.75. With them a little bit off kilter. So they should go twice as far now. So actually one of those cubes is going off there. It's still quite easy to go around them. I'll move them to the side a little bit.
If you move all of them to the far right.
Yeah.
Because they're not gonna completely make the gap. Yeah, so that's the idea, that you get pushed off.
Yeah.
But then this is basically like everything now, so you can just mess with the numbers to get the perfect game experience.
So if we wanted this this one to this one moves before the others, so in fact if we gave this an offset of like 1.25, then I think it'll be further through its sine curve, and it'll probably be coming back to the right hand side when we start. Okay, not quite. Oh no, the sine function takes radians, isn't it? Ignore me. Yeah, but it's like a little bit harder now because they're covering the whole what do you say? The Z range a bit more fully now. Yeah, so
now you can mess around with them. Maybe like make them longer, and then if you make them longer, the player might decide to like jump over them.
oh yeah, I thought we had a jump, didn't we? So if we make them all a little bit longer. So I did that by multi-selecting, pressing the scale tool, and just scaling along like this handle. So now it's a little bit harder. But we still have this jump key, so yeah, we can just leap over all of them. Ooh, I mean, if you fall off the end because you jump too fast, then you'll lose anyway, but... yeah. We'll just jump, and then clip through the win. Any more questions so far?
I have a question.
Go ahead.
If you make the speed of the blocks really fast, does
Yeah.
it smash the guy?
Probably. Let's make it speed 10. So the speed is gonna make it like go a lot further. Ooh. If I like position it right, then it's just gonna go poof. But if we made it something ridiculous like speed is 100. So this speed is actually making the sine wave bigger, so they're moving further. So they're gonna like fly off the screen really far. Okay,
Good
so
effect.
it didn't hit me right on, so it actually just clipped me out the way. But
So if you want to actually change the
There you go.
size, you can, in the sine wave, you can divide by the speed.
yeah, sorry, I'm just saying. If I say that. Hang on.
That didn't
Times by
do what I
speed, times by speed, times by speed. I think. No, hang on. Rather than
wanted. I mean,
Merry Main Dance. No, hang on. Twice it, and then you don't times by speed, right? Yeah. That's maybe not what I wanted to do.
well, this is just like messing with numbers now.
No, I wanted to. Okay, hang on. I think you it. Yeah, you're just messing with things to make it. I think I'm being really silly. My brain isn't engaged. Right, I think this would make it like. Now they're just vibrating.
It's probably going too fast.
It's because they're going really really fast. Yeah. So
No, I think if you put it back to speed on the outside.
yeah.
And then,
Oh, it's
that'll be
because
fine.
it's because I gave it a speed of like 200, didn't I? All right.
If you put the speed back to something like normal.
Yeah, that's it. 5. That's better to what we had before, right? So it's a little awkward when you like clip in between both of them, but
But there we go. There's the basic game.
yeah.
So you can do. From this, you can like do some improvement. Maybe like have some like jumps that the player has to do to get to the goal. Maybe they have to like go up like go higher, jump on some
Something you
other
can do.
platforms and stuff.
If you do speed multiplied in that, I think it just goes through the sine wave quicker, so that should. Yeah, I think that was what I was trying to get to. So yeah, you can have them moving quicker like that. If you multiply it inside the sine wave, then it speeds up the sine wave basically. Although you can get around this pretty easy by just jumping. But yeah, so you could stop people jumping by doing that. In which case you kind of have to be careful and go around this way. But yeah, maybe you just like. Ooh. Yeah, so a lot of game development in Unity is kind of playing around with things in the editor to kind of get something that looks and feels right. Something kind of challenging, or, whatever you're aiming for.
That's a basic game.
This is kind of the world's most basic game. Any additional questions? So obviously we've gone only through the basics today, but we'll kind of build on this.
Can I be annoying and suggest a thing that's cool to show off?
You certainly could.
The fact you can screw things during play mode is really good. So like, if you don't like the way one of those blocks is sine waving around, you don't want to stop it and start it again because you don't know where it's going to end up. You can do it in play mode.
So we're in the scene view now. I can just grab one of these, and I should be able to like move it there, and it will start moving in a different place. So it's quite annoying because you have to kind of catch it as it's moving, but you can pause, move it right there, and then unpause, and it'll stop playing your game again.
My favourite Unity feature.
You can just like move it there, and then you stop pausing it. It's gonna hit the player out the way. Yeah, and then as we mentioned before, once you stop playing, it moves them back where they were. It's non-destructive. So if you make changes you want, just remember that you're gonna have to make them again once it stopped playing. Any more questions?
I think that's all the content we're gonna covered this week, right?
Yeah, I think we've got 15 minutes left of this session, so we're probably going to stop round about there. If you have any further questions, then the Discord's always open. Specifically, if you have any Unity questions, then there's the @Unity role you can call whenever you want on Discord. Hopefully someone who knows how to Unity will come running if you tag that role. So, yeah, you can call that, any point of the week. You don't have to wait for one of these sessions. But if you do have a specific question and you want someone there to help you out live, then these sessions are also a good place to ask for general Unity advice. So if you have any questions throughout the week that you want us to demonstrate in one of these sessions, then just let us know. But for now, I think we are done. So thanks.
Are we gonna cover anything specific next week? I was thinking maybe first-person shooter.
First-person shooter. Yeah, can do. Yeah, that'll have interesting stuff like raycasts or projectiles and that kind of thing. If it's a first-person shooter. Yeah, I think. Yeah, if we. Yeah.
Okay. Cool.
Right. Thanks for coming. I hope you all learned something good about Unity. We will be back next week with first-person shooters. I should do the YouTuber outro now, just for the sake of the recording. But that's just a game dev. No, that's awful. I'm not even gonna dignify that with an ending.
Well, I'll see you around.
Thanks for watching.
Have a good time.